Thank you for joining me today again to talk about limits. We've talked about limits briefly from several different perspectives. We've looked at limits in a graphical form, looking at the graph of a function and determining limits from the picture. Today, we would like to look at limits from an analytical perspective, analyzing the actual relationships of the functions that you are taking the limits of. We began doing this a little bit already when we looked at the rules and properties that limits can have when applied to different types of functions. And we came up with a phrase: if you can plug it in, just plug it in. So let's try to apply that to the limit that we have written on the board today. This is the limit as x approaches 1 of x squared minus 1 divided by x minus 1. If I try to plug in an x value of 1, I get 0 divided by 0. And as I've mentioned to you in class, 0 divided by 0 is not 0. It is also not 1. It is also not undefined. It's something even worse than undefined. It's called an indeterminate form. And the only piece of information that we can glean from an indeterminate form is more work is required. When this happens, we need to take an analytical perspective on the function and see if we can analyze the function in a way that reduces it to perhaps another function that is equivalent everywhere except at one value, and then apply our approach of if you can plug it in, plug it in. So let me start over. The limit as x approaches 1 of x squared minus 1 over x minus 1. If I notice from algebra that the numerator of this quotient is something that is factorable. It's something called a difference of squares, and it factors into x minus 1 times x plus 1. So then I can divide. The x minus 1 divides evenly into the x minus 1 as long as x does not equal 1. X doesn't equal 1 because x is approaching 1. It is getting very close to 1, but never quite making it there. So now I can look at the limit as x approaches 1 of the function x plus 1. And that equals 1 plus 1, which is 2. Let's look at one more function and give you another tool to analytically determine a limit. The second function that we want to analyze is this function x plus the square root of x plus 1 minus 1 divided by x. And the place that causes a problem is as x approaches 0. If we try our phrase again, if you can plug it in, just plug it in, then we get the square root of 0 plus 1 minus 1 divided by 0, which is 1 minus 1 over 0, or 0 over 0. What does this mean? More work. That is it. It is not 1, it is not 0, it is not undefined. It just means that we need to analyze the function differently. So let's start over. The idea behind analyzing the function is changing the way it looks, but don't change its actual value. Keep an equivalent function, or at least a function that's equivalent everywhere but one place, and then analyze that function. One way you learned to do this when you were in algebra is you saw square roots in a denominator very frequently. And when you saw square roots in a denominator, you learned a technique called rationalizing the denominator. And in rationalizing a denominator, you removed the square root from the denominator and made it something that was supposed to be easier to understand. Rationalizing isn't just a method that you can use with a denominator, you can use it with a numerator. So here we have a square root in the numerator, and in order to rationalize, we are going to multiply by the conjugate. The conjugate of the square root of x plus 1 minus 1 is the square root of x plus 1 plus 1. But I don't just want to multiply by that, because then that will change the value of my function. and now I'm analyzing a completely different, unrelated function than the one I began with. So what I really want to do is multiply by 1, because anything times 1 is itself, and I haven't changed the value of the function. So in order to multiply by 1, I am going to multiply by a representative of 1. The fraction square root of x plus 1 divided by the square root of x plus 1 is equivalent to 1. So let me do the multiplication. This is a binomial, but it's the way a difference of squares factors. So the middle terms will cancel out. Let me show you this. Let me distribute the square root of x plus 1 over these two terms. So what I'm doing is taking the square root of x plus 1 and multiplying it by the square root of x plus 1, and taking the square root of x plus 1 and multiplying by 1. The square root of x plus 1 times itself is the square root of x plus 1 squared. And anything times 1 is itself. Then I also want to distribute the negative 1. So when I distribute the negative 1, I get a minus the square root of x plus 1 and a minus 1. I'm still not finished. I have the denominator. So I need to distribute the x over these two values as well. Or don't distribute right now and leave it as multiplying. And we'll distribute it if we need to later. So let me reduce the numerator. If I square the square root of x plus 1, I get x plus 1. And if I subtract these two, they cancel out. And I have a minus 1 here. The denominator remains unchanged. You'll notice that the 1 and the minus 1 cancel out. They add to 0. And I can go one step further and say that this x and this x divide to be 1 as long as x is non-zero. X is non-zero because x is approaching 0 and never quite makes it there. So now I can find a limit as x approaches 0 of 1 divided by the square root of x plus 1 plus 1. At this point, I don't have the more work problem. At any point in the process, if you were to try to, well, if you can just plug it in, you would find that you continue to get 0 divided by 0. I often have people ask me, well, how do you know when to stop, Dr. Mims? How do you know that you can now plug the number in? Well, you're welcome to try that at any point in the process. But if you ever get 0 divided by 0, it's still telling you still have more work to do, so you're not quite finished. Here, it's not telling me that anymore. If I try to plug in 0, I get 1 divided by the square root of 0 plus 1, which is 1/2. And I'm finished. Thank you for joining me. And remember, if you're not having fun, you're not doing it right.